All right, so today we're going to skip to section 6.5 in chapter 6, called the trapezoidal rule. The reason we're going to do that is the 6.2, 6.3, and 6.4 are really, really important sections in this book, and just in calculus in general. And so I want to be there with you guys when I teach it, so that we can go through questions and things as we're going along there. So we're just going to skip to the trapezoidal rule, which is pretty straightforward, I guess I would say. All right, so the trapezoidal rule is just like what you did with rectangles, but now we're going to use trapezoids to estimate area under a curve. Okay, so you really just need to know the area of a trapezoid. If you don't know it, here it is for you: 1/2 times base 1 plus base 2 times the height. So when you were, in good old geometry class or honors geometry, whatever you took, which, I know you guys all loved, right? And I often tell you geometry was my least favorite mathematics course. Still true. Okay, so this was base 1 and base 2. Doesn't matter which one is base 1, base 2, and then this is your height. Okay, well, now when we're looking at these graphs, the trapezoid is going to be on its side. Okay, so you're going to have a base 1, a base 2, and a height is going to be at the bottom, really, and pretend that's straight. Okay, pretend those are perpendicular. So just to get a sense of, I know when you're used to looking at trapezoids, they look like this, but as we're looking at them under curves, they're going to look like this. Okay, so we're just going to go back to that example we did day 1 of the rectangles. Okay, so we've got, we are going to use trapezoids. Oops. I should probably say use the trapezoidal rule to estimate the area under the curve v of t equals t squared plus 1 from t equals 0 to t equals, I think we went to 3. Okay, using 3 trapezoids. Okay, so first we're going to look at it graphically, then we're going to look at it in a table, just like we did with the rectangles. Okay, but we're going to do all that in one day this time. So if I look at 1, 2, 3. I've got 1, 2, 2, 5. 3, 10. Okay, so again, here's my curve. I kind of draw on where I had those rectangles last time. So we've got v of t and time. Okay. So we're going to make trapezoids this time. All right. So, we're going to have like straight lines here. Much better estimate, if you can kind of see my straight lines there. Much better estimate as opposed to using rectangles, right? When we had those rectangles, we had either a lot of area above it, so excess area, or not enough area where it was an underestimate. Here, these trapezoids make a much more accurate estimate, okay? So I'm going to look at my first trapezoid here. So my first trapezoid, so my area, is going to be 1/2 times base 1, which is 1, plus base 2, which is 2, times my height, which is 1. Okay, so that's my first trapezoid. My second trapezoid, 1/2. My base 1 is 2. My base 2, this ends up being 5, times my height, which is this, which is 1. Okay, I'm getting these bases based on, these points I plotted from this v of t. Okay, when I plug 0 in, I get 1, which is where this 1 came from. When I plug 1 in at t equals 1, I get 2. When I plug t equals 2 in, I got 5. Okay, so from when I graphed it, or you can look at that, y equals, to figure out what your output is. And then my last trapezoid, this height, or this base 1, sorry, we're going to call it base 1, is 5, plus base 2 is 10, times my height, which is 1. Okay? So now I'm going to plug that into my calculator, and I don't have my graphing calculator on me, so this is going to take me a second. Like some of you probably will get this faster. So we've got, it looks like 3/2. I'm doing this without my calculator, just for the record. Plus 7/2 plus 15/2, which gives us, 25/2. Should be able to do that. Okay? So that would be the area, or the total distance traveled of this particle in the first 3 seconds. Okay? A much better estimate. Okay? Much closer estimate. We are eventually going to learn how to find it exactly. But so for things where you have an equation, you can find it exactly. But when we have tables, we cannot find it exactly. So that's really where this rectangular approximation method and a trapezoidal rule are more used, is when we have a table of values, which is what we're actually going to look at next. Okay? So let's say another example. Okay, let's say below is a table of values for velocities of a particle at a given time, and we'll do seconds in centimeters per second. Okay, and we want to figure out, we're going to use 4 trapezoids to find the distance traveled. Okay, so we'll have time, and we're going to put our time in seconds. We're not going to convert anything this time. And velocity is in centimeters per second. Okay, so I would right at this moment ask you guys for some numbers, but since I'm not there, let's do 1, 3, 7, and 10. Okay, so we'll do it in 10 seconds. And I'm going to ask my children for some of their favorite numbers. Ella, what's a number?
27.
Okay, so we're going to do 27. Jack, what's a number?
What?
I need a number. Can you give me a number? Like between 10 and 30.
21.
Okay, so we're going to do 21. And then Ella, another number between 10 and 30.
2.
10 and 30.
Oh my god. 7. No, not 7. I mean 17.
17, that's a good one. Jack, can you pick a number under 17? But 13, perfect. Okay, so we've got our numbers. Okay, so now we're going to use a trapezoidal rule. So here's 1 interval, here's 2, there's 3. Oops, I said use 4 trapezoids. We're going to use 3 trapezoids. Sorry about that. I can hear some of you sighing right now because I changed something and that irritates you, so I'm sorry. All right, so we're going to find the distance traveled over those 10 seconds. So the distance is going to be 1/2. Here's my first interval, so I have 27 plus 21. And then this height, or that total time I went, was 2. Okay? Plus 1/2 times 21 plus 17. And then that distance is 4. Plus 1/2 times 17 plus 13. Those are my 2 bases. And then times this height is going to be 3. Okay? So, 2 times 1/2 really is just 1. So we've got 27 plus 21, which is 48, plus This is going to be 2. So I have 21 plus 17 times 2 gives me 76, plus 17 plus 13 does 30, divided by 2 gives me 15, times 3 gives me 45. So now when I add these, I am adding with a calculator right now, we get 169 centimeters. Okay? So like I said before, this is really more of the type of example you will see on the test as well as probably on the AP test. They're not going to give you something that we did up here. I just visually like to use something like that. And there could be, I mean, I shouldn't say they won't, because there could be. It's just more practical that you're going to use something like this here, because we will learn how to evaluate these exactly. And so that's when you would do it exactly then if you could. Okay, so again, Mr. Cruz has your homework, and please do your best to get it done. Do your best to get all these assignments done for Monday, and hopefully we can just have like a few questions we need to go over. So use your weekend to finish up whatever you need to finish up. And I'll see you guys Monday.